Hello everyone, my name is Muhammad Usama Salim and I am a PhD student at Texas State University. Today I'm going to talk about the utilization of waste materials such as glass and Cenosphere in cementitious composites. So the article that I have chosen for this presentation is the mechanical and durability properties of high performance mortar containing binary mixes of Cenosphere and waste glass powder under different curing regimes, which is published in the Journal of Materials Research and Technology. Now the objectives of this study. The objectives of this current research are to evaluate the performance of Cenosphere and waste glass powder on the properties of cementitious mortar. In this study, Cenosphere and waste glass were replaced by cement in a varying percentage of 0 to 20% to evaluate their performance based on different curing temperatures and curing conditions. Two different curing temperatures such as ambient and high temperature including 80 centigrade grade were applied with two different curing conditions such as water curing and air curing. Moving forward, we'll talk about some specifics of the article. Table 1 shows the chemical composition of all binders, including cement, Cenosphere, and waste glass powder. Table 2 portrays the physical properties of Cenosphere, including the maximum size of Cenosphere that was used in this study was 300 micrometers, while Table 3 depicts the mixing proportions and nomenclature of all mixtures. The dose of superplasticizer was set as 3% with a water to cement ratio of 0.35. Now we will talk about some results. Figure 1 explains the compressive strength analysis of all mixtures under both curing conditions and curing temperature. High temperature water curing showed the maximum strength in all curing types due to accelerated hydration that can be seen in the figure 1. The control mix showed a compressive strength of 101 megapascal and incorporation of waste glass and Cenosphere apparently reduced the compressive strength. However, with 10% incorporation of Cenosphere and waste glass powder, the compressive strength has slightly increased. The gentle increase in compressive strength at this replacement can be credited to highest packing density and lowest void ratio in this design mix. And the second reason may be attributed to the amorphous silica present in Cenosphere that reacted with calcium hydroxide in cement and promoted hydration product which ultimately increased the compressive strength. Figure 2 shows the flexural strength of all specimens under all curing types. It is evident from figure 2 that flexural strength is increased up to 10% replacement of Cenosphere and found maximum at 10% replacement of waste glass and Cenosphere and then gradually decrease. This pattern is prominent in all curing types. Flexural strength increment is because of higher pozzolanic activity of Cenosphere and waste glass powder and tightened bonding between the particles. Secondly, the pronounced bending resistance of Cenosphere is because of the presence of high aluminosilicate constituents that provide huge energy absorbing and dissipating properties leading toward the increased flexural strength. Figure 3 illustrates the relative compressive strength of specimens exposed to higher temperatures such as 200, 400, and 600 centigrade grade. At 200 and 400 centigrade grade, the compressive strength increased, which can be attributed to evaporation process, which generates friction between the layers of mortar, and hence more load is required to break the sample. Plus, hydration rate also increases at higher temperature, leading toward the thick formation of calcium silicate hydrate gel and increases the strength. However, the decrease in compressive strength at 600 centigrade grade can be attributed to the decomposition of hydration product. But it is interesting to know that at 600 centigrade grade, the compressive strength of purely Cenosphere base mixture neither decreased nor increased due to its excellent thermal stability. Figure 4 presents the percentage compressive strength loss due to acid attack. The compressive strength loss was found more at higher temperature than ambient temperature. Compressive strength loss due to acid attack was found maximum in control mix, while Cenosphere incorporation reduced the compressive strength loss. which can be due to the increased packing density by filling the voids, which prevents the ingress of acid. The second reason could be because of pozzolanic reaction induced by Cenosphere, which fills the pores with hydration gel and prevents the acid penetration. Finally, the conclusions from the above discussion, it can be suggested that Cenosphere has a high potential to be used as a supplementary cementitious material and a partial replacement of cement in concrete and mortar. It modifies the rheological, mechanical, and durability properties of cementitious composite when used in combination with waste glass. That will definitely promote the sustainable built environment. So based on the current research, it can be concluded that 10 to 15% incorporation of Cenosphere with 5 to 10% replacement of waste glass powder can enhance the properties of cementitious composites. This slide presents the weakness of the current article and the potential research gap to be addressed to further validate the performance of Cenosphere waste glass based supplementary cementitious material. So the first thing is the effect of different water to binder ratio is not studied in the current article. Secondly, the life cycle assessment of Cenosphere based cementitious composite is required to assess their environmental impact, and the effect of Cenosphere replacement on the long-term durability properties such as freeze thaw, chloride penetration, and carbonation, etc. are also not studied. Thank you so much for watching this video. Please provide your thoughts in the comment section. Have a good day. Thank you.